Alright, so for number 2, again, you want to graph this function without the use of a calculator, but we don't have to do the properties for this graph. So we're really just looking to find the elements in order to graph the function, which again include your point discontinuity, it includes your vertical asymptote, your horizontal asymptote, your x-intercept, and your y-intercept. And we'll also go ahead and write the vertical and horizontal asymptotes if there are any in terms of limits. We're also going to want to do a sign analysis to graph this, so I'm going to go ahead and put a number line right underneath my graph. And then I can get started by factoring the top to see if I do have a point discontinuity. So I'm looking for two numbers that when I multiply get -5 and add to get 4. So those two numbers are going to be +5 and -1, so I'm going to go ahead and fill those in. Now if you notice, I don't have anything I can cross out, so I don't have a point of discontinuity here. And this kind of function is actually kind of interesting because if I did have a point discontinuity, this would actually just be a straight line. Okay, because you'd have to factor out, and you'd cross out one of the factors, you'd just be left with a linear equation. However, this one doesn't, so we're going to go ahead and continue. We're going to go ahead now and look for my vertical asymptote. My vertical asymptote is when the bottom is 0, so that will be the value of 2. So x equals 2 for my vertical asymptote. And you're going to want to go ahead then and graph that. Now since this is a top-heavy function, again, that means that the power on top squared is bigger than the highest power on the bottom, which is 1. So since this is top-heavy, I do not have a horizontal asymptote. However, I do have a slant asymptote. So to find my slant asymptote, I'm actually going to refer back to my original function and perform synthetic division. Now, we said that my vertical asymptote was 2 because it makes the bottom 2. That's the number that I'm going to use for my synthetic division. And then I'm going to use the coefficients of each of these terms. So 1, 4, and -5. So for synthetic division, you're going to bring down the first number, multiply 2 times 1, and put it here. Add, multiply 2 times 6, put it here. Add, and you get 7. Now, the only thing that really matters in this case is this number and this number. So my slant asymptote is y equals 1x plus 6. I really don't even need my remainder in this case. The only reason why I would need my remainder is if I were rewriting, but I'm not rewriting. So my slant asymptote is just y equals 1x plus 6, or x plus 6, which is a y-intercept of 6, 1, 2, 3, 4, 5, 6, and a slope of 1. So up 1 over 1 or down 1 like this. Okay, and then I'm going to go ahead and draw on that asymptote along those points. So here's my slant asymptote. Now as you can see, they don't intersect. They're going to intersect up here. Okay, and you're actually going to get a portion of this graph, as you'll see in just a second, that's going to be up in here, but we'll talk about that in just a minute. So to find my x-intercept, that's when y is 0. That's basically when the top is, or when the x-intercept is when y is 0. So if I do 0 equals this, that's going to cancel out the bottom, and it's going to basically just be the opposite of these two. So my x-intercept is 5 and 1. My y-intercept is when x is 0, so I have 0 plus 5, 0 minus 1, and 0 minus 2. So that's going to be 5 times -1, which is -5, divided by -2, which is -2, so -5 over 2 is just +5 over 2. So my y-intercept is going to be up about 2.5, which is right here. And then my x-intercepts are 1, 2, 3, 4, 5, and 1. Alright, so now you can kind of see where this graph is going. Okay, so this is going to follow that asymptote. It's going to curve around, hit the y-intercept, and then come back down. So really, without even doing a sign analysis, this problem is pretty easy to see where it hits. And really all you're going to use for your sign analysis are your x-intercepts and your vertical asymptote. So obviously this portion of the graph is going to be below. You could test it out. This portion is going to be above. This portion here is going to be below, and then of course it alternates, and you know you're going to have that above over here. You could test it and do 10 plus 5, which is positive, 10 minus 1, which is positive, 10 minus 2, which is positive, so again, you're getting a positive number. So the other portion of the graph is going to look like this, and it's going to be up in this area. But again, the way that this graph is drawn, it makes it very difficult to see that. Okay, writing our limit statements, we'll go ahead and write our vertical asymptote in terms of limit statements. So limit as x approaches 2 from the left, the function, so what does it do? Here's my vertical asymptote. As it approaches from the left, it goes to negative infinity. And then the limit as x approaches 2 from the right, the function goes to, and again from the right, it's going to go to positive infinity. Alright, and that's it.